Hey internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. So we have an aircraft flying over a city at an altitude of 6,400 meters. Inside the plane is 46 kPa. We want to find the local atmospheric pressure, so PATM, in kPa and in millimeters of mercury. They give us the air density, which is 0.828 kilograms per meter cubed, and the density of mercury, which is 13,600 kilograms per meter cubed. Step 1, draw your free body diagram, your FBD. This will help you visualize the problem. So this triangle represents a plane, and this L block represents the city. And we are at an altitude of 6,400 meters. Inside the plane is 46 kPa. Step 2, list all the given values and find the unknown. So we're trying to find the PATM as well as the height of mercury. So they give us the pressure inside the plane, which is 46 kPa. They give us the altitude height, which is 6,400 meters. They give us the density of air and mercury, respectively. So 0.828 kilograms per meter cubed and 13,600 kilograms per meter cubed. Step 3, find the formula for the height of mercury. So that is H is equal to P divided by rho multiplied by G. So rho is the density, and it will be the density of mercury. Let's just make that a little bit more clear. So why are we starting with that formula first when the atmospheric pressure is also needed? So in order to find it, we need to find the atmospheric pressure. So step 4, find the formula for the atmospheric pressure. So that's the pressure of the plane plus the pressure at altitude. So we're missing that portion for the altitude, so that's our next step. Step 5, find the pressure with rho GH. The density is air in this case, so we'll clarify that. Okay, and the height is 6,400 meters. So we just plug and play. This is the air density, this is gravity, and this is the height at altitude, and this is the conversion factor. So the pressure at altitude is 51.985 kPa. Step 6, find the atmospheric pressure. So that's half of the question, what we're trying to find. So we add them together, 46 kPa plus 51.985 kPa. So that's 97.985 kPa. So that's half the question solved. Now to find it in millimeters of mercury. So that is the atmospheric pressure divided by the density of mercury multiplied by gravity. So we're just going to plug and play. So the atmospheric pressure, PATM, is found here in step 6. The density of mercury is given, and we assume gravity. The conversion factors, they just convert the units to cancel out all of that into what's left is millimeters. So the height will be 734.43 millimeters of mercury. Okay. Disclaimers: the method is correct. However, I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Before we leave, I highly encourage you to save this video onto your PC using snipping tool. While I follow all copyright laws, sometimes things just happen. If you don't have snipping tool or you're on a Mac, you can use the Mac equivalent. So if it's not there in your taskbar, type in Windows search and type your snipping tool. Once you have it open, click on video option, then click on new. Left click and drag the rectangle to cover the YouTube screen. This is just an example. Hit the start button and snipping tool. Wait for the countdown. Then hit the replay button on YouTube. Let the video finish. Click the red square and snipping tool to stop recording. And then save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe. Share with your friends because this is a made up question, so they probably won't be able to find it. If you find a mistake or if you got questions or comments, leave it in the comment section. I'll get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.